Today I come to you again with Obeng series. Our topic for discussion today is the crystalline lens. The crystalline lens. Students, remember that there are several types of lenses. Some people use lenses in the glasses they are wearing. There are other types of lenses that are used in ophthalmic equipment. We also have contact lenses. So the natural one, which is in our eye, where you see in this particular picture, is known as crystalline lens. Crystalline lens. Crystalline because it is rich in some type of protein that are known as crystallines. So that's why it's called crystalline lens. For the purpose of this presentation and to avoid repetitions, if you hear me talk about lens, I'm referring to the crystalline lens. Whenever you are making reference to the natural one in your eye, you say crystalline lens, don't say lens. But for the purpose of the presentation, whenever you hear me say lens, I'm referring to the crystalline lens. So, this is the crystalline lens, okay? It is found behind the iris, as you can see, okay? It is a transparent, alright, biconvex because it has two convexities, one anteriorly, another one posteriorly. Structure which is avascular, found at the anterior segment of the eyeball. So it is the last structure you see when you talk about the anterior segment of the eyeball. Look at the crystalline lens here in this other particular picture, okay? Look at it. This is a crystalline lens. It has been slashed into two equal halves. So this is one half of it, okay? So in this particular picture, here is a crystalline lens found behind the iris, okay? In this one, this is the crystalline lens over here, okay? This is a crystalline lens, all right? This crystalline lens, and we talk about them. So you realize that there are certain structures that hold the crystalline lens in place. These are called zonules of Zinn. Zonules of Zinn, okay? They are attached to the ciliary muscle of accommodation. Zonules of Zinn. You can find them here. These are the zonules of Zinn. Zonules of Zinn. Here they are not quite prominent, but you can find them here. And this is the ciliary body. Okay. So the zonules of Zinn are inserted within the ciliary muscle of accommodation. This is the crystalline lens, and look at the zonules. Okay. So the zonules are found in between the crystalline lens and the ciliary body. Okay, they attach the crystalline lens to the ciliary body and they hold the crystalline lens in place. So, what are the functions of the crystalline lens? Well, it helps to maintain its own clarity or its own transparency. Number two, it helps in light refraction and transmission. So, it helps in light refraction and transmission onto the retina. Okay. The third and the last but not the least is that it provides accommodation. Accommodation is nothing else but when someone is looking into the distance and all of a sudden the person looks at his watch, mobile phone, or something very close to him, the eyes become accommodated. Accommodation just means looking at something very close to you after you shifted your sight from the distance. So, the crystalline lens at birth weighs 90 milligrams, but in the adults, it weighs 255 milligrams. It measures 10 millimeters in diameter. Okay, 10 millimeters in diameter. It's interesting to note that the anterior and posterior poles, okay, are joined by an imaginary line called the axis. So anterior and posterior poles are joined by an imaginary line which is known as what? The axis. Okay, axis. So axis will be from this point to this point. This is imaginary line joining the anterior and posterior pole. So it's called what? Axis. Okay. Now, lines on the surface of the crystalline lens. Okay, you may have several lines, concentric. Let me see. Several lines on the surface of the crystalline lens. Okay, they keep moving round and round. Okay, from one pole to the other, they are called what? Meridians. So concentric lines that move around the crystalline lens from one pole to the other, these are called meridians. And the greatest meridian is known as what? The equator. The equator is what? The greatest meridian. Okay, the equator. Look at the equator here. The equator forms the greatest meridian. Look at the equator. Okay, it has the greatest meridian. So the equator will be here from this area to this area. It forms the greatest meridian. Okay, so histologically, the lens is made up of certain features which you should be aware of. Okay, one, from anteroposteriorly, it has capsule. That's the most external histological layer. This is the capsule of the crystalline lens. It's the most external histological layer. Okay, it is far thicker at the anterior than the posterior aspect of it. So this is the capsule. Okay, the dark zone is the capsule. As you can see in this particular picture, it's far thicker at the anterior area and is thinner posteriorly. That's the capsule of the crystalline lens. Okay, so going inwards from the capsule, the next layer which you see is the epithelium. Look at the epithelial layer here, well organized. Have you seen? This is the epithelial layer here. There's something you should know about. The posterior aspect of the crystalline lens does not have epithelial layer. It's only the anterior part which has the epithelial layer. Look at the epithelium of the crystalline lens over here. It comes just after the capsule. For your information, it is the epithelial layer which brings about the capsule. So when there occurs mitosis within the epithelial layer, then it helps in further increasing the size of the capsule. So from the epithelium, the next layer you meet is the cortex. Okay, is the cortex. Is the cortex. This is the cortex. Okay, that's the cortex. And from the cortex, the next one you meet is what? The nucleus. The nucleus of the lens. Let's go to this picture once again. So this is the lens capsule, okay, which is far thicker at the anterior portion and very thin at the posterior. Apart from the capsule, the next layer which comes is the epithelial layer. Okay, the epithelial layer is non-existent as the posterior part of the crystalline lens. Then you have the cortex. Okay, this is the cortical area of the crystalline lens. Okay, that's the cortical layer. Then from there you have the nucleus of the crystalline lens. Is that clear? So that is it. Of note is the fact that the epithelial cells are metabolically active. Okay, They carry out all normal cell activities, including biosynthesis of DNA, RNA, protein, and lipids. They also generate ATP to meet energetic demands of the crystalline lens. So, the epithelial layer is that which is in charge of going through process of mitosis to give birth to the other cells that are found within the lens. So one, they help in replenishing or maintaining the capsule or producing the lens capsule. Two, through mitosis, they release cells that helps information of the cortex, and the cortex fibers after a while they then migrate to become the nucleus. So the oldest cell, no cell is lost within the crystalline lens, and the oldest cells are found within the what? The nucleus. So the older we are, the bigger the nucleus becomes, because every cell will end up becoming part of the nucleus. So the older people have larger nucleus. As I said, it helps the epithelial cells, they help in what? Biosynthesis of deoxyribonucleic acid, protein, and then lipids. They also help in generation of adenosine triphosphate to meet energetic demands of the crystalline lens. Okay, so again, as I repeat, the epithelial cells go through mitosis and transform into what? Lens fibers. Okay, after they get divided, they transform into what? Lens fibers. During their during this procedure, they lose organelles. Okay, like what? The nucleus, mitochondrium, and the ribosomes. Because if they still contain this particular organelles, then these organelles can cause scatter of light and cause what? Decline visual acuity. But once they lose these organelles, they become transparent, migrating to form part of the cortex and finally the nucleus. Let's talk about some biochemistry of the crystalline lens. Okay, biochemistry of the crystalline lens. Of note is the fact that the lens is made up of 33% protein. Okay, you see like this, 33% of it is protein, 66% of it is water, and 1% is made up of other substances including electrolytes. Okay, vitamin C, vitamin E, and other free radical scavengers. So, among the lens proteins, okay, that the crystalline lens is rich in, we have two main types. We have the water soluble proteins, okay, and then water insoluble. Water soluble and water insoluble. The water soluble proteins account for 80%. Sometimes to some of them it could be 80 to 90%. Alright? So they are called crystallines. So the water soluble protein account for 80 to 90% of the proteins within the crystalline lens. And this percentage, which is 80 to 90%, are specifically called what? Crystallines. And that is how come the structure derives its name, crystalline lens. Okay? So among the crystallines are alpha crystallines, beta crystallines, and then gamma proteins. Okay, so we have what? Alpha. So instead of crystallines, you can also call them what? Proteins. You can have alpha proteins, beta proteins, and gamma proteins. Okay, studies have shown that the gamma and then the alpha, the beta and then the gamma proteins look so similar at the microscope, so much so that some scientists call them beta gamma proteins. But for our purpose, we shall always divide them into three: alpha proteins, beta proteins, and then gamma proteins. Okay? For your information, alpha proteins have the largest molecules, so they are the largest in molecular weight, while beta proteins are those in highest quantity that you can ever find in the crystalline lens. The gamma have the smallest size and the smallest molecular weight. Okay, so the water insoluble proteins are divided into what? Urea soluble and urea insoluble proteins. Okay, as we are young, the crystalline lens remains transparent because it is 80% crystallines and a lot of it is what? Water soluble. But as we grow, it starts turning into water insoluble. Okay, and that is when opacification starts coming in for the development of what? Cataracts. Alright, so it is also of note to realize that the lens has several enzymes which work against free radicals or oxygen damage. When I talk about free radicals, oxygen damage, remember when a baby is born, their skin looks so fresh. Okay, as we continue growing, the skin starts becoming hard, difficult, okay, and it starts having marks. It's going through a process of aging. We call something programmed cell death. Programmed cell death. And programmed cell death only occurs when there are free radicals. Free radicals are substances in our body that bring about aging, tissues becoming older than they should be. Okay, so every day we lose cells from our skin, and that means the skin becoming what? Older and older. So without free radicals, tissues will not grow. So when you hear free radical scavengers, they are medications that stop programmed cell death. Okay, medications that stop what? Programmed cell death. So they could be in form of enzymes, okay, or substances. So within the crystalline lens, in order to avoid it becoming very old and forming cataracts, there are certain free radical scavengers. Among them are glutathione peroxidase, catalase, superoxide dismutase, vitamin E and vitamin C. I repeat, glutathione peroxidase, catalase, superoxide dismutase, vitamin E and vitamin C. But for the presence of these free radical scavengers, a lot of people in the world who have developed cataracts and opacification of the crystalline lens. Okay, remember that the crystalline lens has sutures. I'll show you one very soon. Look, this is a suture. Look at a suture line within the crystalline lens. Okay, all right. So when you examine a patient, you realize that there are two major ones that you can see. We have the anterior and then the posterior suture. Okay, the anterior one is what? Y shaped, and the posterior one is inverted Y shape. So the anterior suture is what? Y shape, and the posterior suture is what? Inverted Y shape. Okay, all right. So let's talk about accommodation which occurs within the crystalline lens. Okay, accommodation. So during accommodation, for you to shift your sight from the distance and all of a sudden look at something which is close to you, the crystalline lens needs to go through some modifications, okay, without which accommodation will not take place. So during accommodation, what are some of the findings? The ciliary muscle contraction. This is the ciliary muscle here, okay, it contracts. All right, then the ciliary ring diameter, what happens to it? It reduces. Okay, let's talk about tension within the zonular fibers. During accommodation, the crystalline lens become more globular. therefore reducing the tension, okay, within the zonular fibers of zinc. What happened to the lens shape? The lens shape, instead of being biconvex, it becomes more spherical or more globular. Okay, it also increases its axial lens thickness. The lens thickness becomes what? More. The anterior lens capsule curvature becomes more steep because it has become more globular. Okay, so it becomes more steep or steeper. Then let's talk about posterior lens capsule curvature. There's minimal change over there. Okay, so this is anterior lens capsule. During accommodation, okay, it becomes more steep, okay, anteriorly, but the posterior portion, there's minimal change over there. Is that right? And let's talk about dioptric power within the crystalline lens. The total dioptric power in the crystalline lens is 40 to 45 diopters. But during accommodation, it will what? Increase. Alright? And then we have what? Equatorial diameter. During accommodation, the equatorial diameter decreases. Okay, because the lens will become more globular and more spherical. But there are three processes that always occur together. We call them synkinesis of processes. Three of them: accommodation, meiosis, and what? Convergence. So accommodation, you have explained it. Meiosis is when your pupils become smaller than usual. And the convergence is when the two eyes come closer to each other. Alright? So at this juncture, I would like to end my lecture. And if you have any questions, you may put them down. When we meet, you can clarify them. Learn hard. Go through this YouTube material several times for better understanding. That's it.